Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, so this is the geometry final I gave this year, 2021. And since school's coming to an end tomorrow, I won't see my geometry class again. I decided to make this video to give them the solutions to their test, and I passed them back to them. And it's up to them if they want to watch this or not. But this might benefit you if you haven't taken your final yet. So here we go. So I start with number 1, and it says the equation x squared plus y squared minus 4x plus 2y equals b describes a circle. Determine the y coordinate of the center. So we want to know the y coordinate of the center. The y coordinate of the center. So I need to find the equation of the circle. And since this is not in standard form, we need to complete the square and do that. So first thing I'm going to do is combine my x's. And to complete the square, you have to take b and divide it by 2 and square it. And half of -4 is -2. -2 squared is 4. And I always underline that because I'm going to add it to the other side. And then I'm going to have y squared plus 2y. And then I'm going to take half of 2, which is 1, and square it. 1 squared is 1. And I'm going to add that to the other side. And that is b. And so then I have to add 4. And I have to add 1. Okay, now I can complete the square. Okay. And 4 plus 1 is 5, so I'll just leave that b plus 5 for now. And when I complete this square, I take half of b, and that's what goes in my parentheses. So it's x minus 2 squared will give me this quadratic, and y plus 1 squared will give me this quadratic. So the equation of a circle is x minus h squared plus y minus k squared equals r squared, where h comma k is my center and r is the radius. Okay, so if I do h minus k, minus a -2 is plus 2, so therefore my h, or my x value of my center, is going to be the opposite of -2 or 2. Or you could say to yourself, what makes this parentheses 0? And -1 would make this part 0. So there's my center, 2, -1. Determine the y coordinate, and there's your answer. Okay, now it says the radius of the circle is 7 units. What is the value of b? So remember that radius in the equation is squared. So 7 squared equals 49. And I want b plus 5 to equal 49. So I say b plus 5 equals 49. Subtract 5 from both sides, and we get our answer, b equals 44. So there is the answer to part B in number 1. All right, number 2. In the figure, the triangle GHJ is similar. So there's the key word there. Let me highlight that. Triangles are similar. What does similar mean? Well, angles are congruent and sides are proportional, corresponding, that is. So the first thing I'm going to do is look at this and say, okay, so if it says based on this information, which ratio represents tan of h? So I label my diagram h. There is my reference angle in this triangle. And then I look, and h is in the middle in the name, so therefore it has to go with the middle letter in this name, and it's q, so that tells me q is congruent to h, and the sides are proportional. So if we're looking for tangent of h, if I said the tan of h, well, I don't have any number values over here, so I can't figure out the scale factor, but I do know that it's equal to the tangent of q because the angles are congruent. And I have numbers for tan q. So I'm going to find tan q, and that'll be my answer to this problem. So the tangent of q is opposite over adjacent. So therefore, the tan of q is opposite 8. This is opposite. and this is adjacent, and this is the hypotenuse. So I need opposite over adjacent. That's 8 over 15. And 8 over 15 is choice A. And that's page 1. Okay, page 2 brings us to number 3. And it says, in the figure shown, line CF intersects line AD and EH. So therefore, CF is a transversal at points B and F, respectively. Part A, given angle CBD, I'll label it, CBD's right here, is congruent to angle BFE. That is a given, okay? Well, now those are corresponding angles, so that tells me that these two lines, AD and HE, are parallel. It did not tell us that, but we know that now because the corresponding angles are congruent. We want to prove that angle. What we want to prove, I'll put in red. So we want to prove this. Angle ABF is congruent to angle BFE. So we want to prove these two angles congruent. Okay? So number 1 says, or statement, angle CBD is congruent to angle BFE. Angle CBD is congruent to angle BFE is right here. That is a given. Okay, be careful. I had students get that wrong. I put it on there so it'd be kind of like a freebie, and they passed it up. So be careful. Read the statement and go back and look at what was given. All right, statement now says angle CBD is congruent to angle ABF. CBD is congruent to angle ABF. That is this angle here and this angle here. Well, they're vertical. Vertical angles are congruent. Statement ABF is congruent to angle BFE. Reason. So now we look at this. CBD is congruent to BFE and CBD is congruent to ABF. So when two things are congruent to the same thing, they're congruent to each other. So if this is equal to this or congruent to this, and this is congruent to that, then this is congruent to that. And that is the transitive property. So that is F. Okay, so that's the transitive property. So that's part A. Pretty simple. And then I come back to the problem on the part B. And again, it says given. So let me erase these now. Let me erase this. Okay, start over. Angle CBD, label it with green. CBD's here is congruent, is equal to the measure angle BFE. Okay, so it's equal to this. Prove that angle BFE plus DBF, so I'll number this 1 and I'll number that 2. So we're proving that BFE, which is angle 1, and DBF, which is angle 2. Sometimes it makes it easier to number them like this. Now I want to prove that angle 1 plus angle 2 equals 180 degrees. So first statement they give is the measure of angle CBD equals the measure of angle BFE. Yeah, given. Number 2, statement M, the measure of angle CBD up here, okay, plus the measure of angle DBF right here is 180 degrees. Well, CG is a straight line. So two angles on a line are supplementary because they are linear pairs. So it's B, angles that form a linear pair are supplementary. All right. And then finally, it says statement measure of angle BFE plus the measure angle DBF equals 180. So look at my two equations. So I have, let's call this A equals B. And now I'm saying A plus B equals 180. And then down here, I have BFE, let's call that B, plus DBF, I'm sorry, BFE is B. Let me get this straight. CBD is A, BFE is B, CBD is A. I lettered that the same. DBF is not the same as that. DBF I'll call C. So now it's saying BFE, which is B, plus DBF, which is C, equals 180. Okay. Well, we're told these two are equal here. So CBD's here, CBD's here. It's equal to BFE. So now I can say BFE in place of CBD. Notice how this is the same and CBD became BFE. Well, CBD equals BFE, so therefore we're substituting, and that's all that is. So that is the substitution property of equality. Okay, so there's the proof on that page. Okay, page 3 brings us to the problem number 4 on the test, and it says the circle with a center F, right there, is divided into sectors. Okay, 5 different sectors. In circle F, EB is a diameter. All right, so there's a clue. EB is a diameter. The radius of circle F, the radius is 3. All right, so that's the 2 givens. So here we go. It says match each arc length to its subtended central angle. And here they are, and it's just a simple matching. Subtended central angle, angle AFB. Here's the angle AFB. So what we're trying to find is the length of this arc AB. So to find the length of arc AB, the equation of an arc is the angle divided by 360 times, and remember it's length, arc length. That means it's a portion of our circumference, and circumference is 2 pi r. So this is a fraction of the circle, if you will. It's 120 degrees out of 360, and then you reduce that, and 12 goes into 36 3 times. So this would reduce down to 2 pi r, because the 120 will cancel, and it will leave 3 down below. Okay, or is that right? 12 goes into 36 3 times, yes. And I forgot my r. I should substitute that in here. I'm jumping steps here. So let me just write the formula first, then substitute the givens. So the formula is the angle over 360 times 2 pi r. So for AB, it's going to be 120 over 360 times 2 pi 3. And think of that as over 1. So 120 and 360 will reduce down to 1/3 times, and 3 times 2 is 6 pi. So that's the same as 6 pi over 3, which equals 2 pi. So the answer is right here. That goes here, 2 pi. We're going to do the same for each one. Now it's saying BFC. BFC is right here. It's 45 degrees. We're looking for this arc length right here, arc BC. So I would say BC equals the angle measure over 360 times 6 pi. Now that's going to stay the same every time. 2 pi r is 2 pi r. Okay. There are 8 45s in 360. So this is going to equal 6 pi divided by 8. The 45 over 360 is 1/8. 1/8 times 6 pi is 6 pi over 8. That reduces to 3 pi over 4. And that is right here. So 3 pi over 4. Okay, next thing, I'm looking for CFD. CFD is right here. That would be the arc length right here, DC or CD. So arc CD is going to equal this angle measure over 360 times 6 pi. Okay, and these reduce, the zeros cancel, 3 goes into 36 12 times. So I'll just write it over here. It's going to reduce down to over 12, and that is going to reduce down to pi over 2. So this is pi divided by 2, which was here. And then finally, the last one, angle AFE is right here. So we need to find this arc length. So the arc length is the AE. Let's call it AE. Okay, arc length AE equals central angle. They didn't give it to us. Uh-oh. oh wait, read this. EB is a diameter. That's a straight line. This is a semicircle, 180 degrees. If this is 120, this has to be 60. So it's going to be 60 over 360 times 6 pi. This reduces. 6 over 36 reduces to over 6. So this will cancel and put a 6 down below. And 6 over 6 reduces to 1, and we get pi. And that was this choice right here. Okay, number 5 says the degree measure of an angle in a right triangle is x, and the sine of x is 1/3. Which of these expressions are also equal to 1/3? Select all that apply. All right, so the first thing I want to do is I want to draw a triangle. So let me bring one in. Okay, so here's my triangle. And let me just adjust it a little bit so it's not looking isosceles. Okay, so here we go. Here's our triangle. So it says the degree measure of an angle in a right triangle. So it's a right triangle is x degrees. The sine of x is 1/3. Remember, sine is opposite over hypotenuse. So opposite is 1 and hypotenuse is 3. Okay, I can find this side by doing the Pythagorean theorem. So it'd be 9 square root or c squared minus b squared, which is 9 minus 1, which is 8. So this would be the square root of 8 if you needed to know. And that'd be 2 root 2. Okay, but that isn't necessary for this problem. It says which of these expressions is also equal to 1/3. So cosine of x, no. Cosine of x would be adjacent over hypotenuse. That would be this 2. So I'm going to put the answers over here. That'd be 2 root 2 over 3, and that's not 1/3. Cosine of x minus 45. Well, the only time that is true is if this triangle were an isosceles triangle, and obviously 1 does not equal square root of 8, so that's not true. So nothing to do with 45 is going to work. Cosine of 60, well, the only time we would have a 60 is if we have a 30, 60, 90 triangle, and that's x, 2x, x root 3. And that is not the case because these aren't, this is not half of square root of 8. So this is out. But the cosine, so what are we doing? Sine of 1/3. So sine is opposite over hypotenuse. The cosine of 90 minus x would be this angle here. Remember, the two acute angles in a right triangle are supplementary or add up to 90. So the cosine of 90 minus this would be y. So the cosine would be adjacent 1 over 3. So the answer is E. Okay. You just have to remember that the sine of this angle, sine of x, equals the cosine of y. In a right triangle, the sine of one acute angle is equal to the cosine of the other. And so the answer is E. Okay, problem number 6. What page are we on? We're on page 4. Problem number 6. The figure shows line R. See the R right here? This is line R. Points P and T are on R, and point Q is not on R, also shown as ray PQ. Okay, consider the partial construction. Notice what that just said. Partial construction of a line parallel to R through Q. That is the key to this problem. And it says what would be the final step in this construction. So they took a compass, they put the stylus here, and they drew an arc. And then they put the stylus here, and they drew this arc here. And then they copied it. They did that up here, and then they copied it down here. And then they're going to do it again at Q. Okay, so the next step is you want to, it's done. This is the point you would draw the line through. So you would draw a line. This is down a little bit, but you get the idea. You want this parallel to R. Okay, says parallel to R through the point Q. So this would be the line that you want to draw. So Q through this point here, continuing. So the last final step would be draw a line through P and S. No, this is not parallel. Draw a line through Q and S. Yes. I'll just go through each scenario. Draw a line through T and S. No. Draw a line through W and S. No. That would be parallel to ray PQ. Okay, so the answer is B. Part B. Let me bring that up a little. Once the construction is complete, which of the reasons listed contribute to providing the validity of the construction? So what do we have here? We did an angle, we copied an angle. Okay, so when two lines are cut by a transversal and corresponding angles are congruent, the lines are parallel. That's what we're doing. When two lines are cut by a transversal, vertical angles are congruent. These lines, that never proves parallel. This being congruent to that never proves anything parallel. Okay, it's just two lines going through a point. And definitely we didn't bisect a segment and we didn't bisect an angle. So the answer is A. Okay, page 5, problem number 7. It says in the coordinate plane, two triangles with these vertices are similar. All right, so let's first highlight that. The triangles are similar. Okay, they're dilation with a center at one of these 3 points, and we need to find their scale factor. Okay, so it's a pretty simple question. All you have to do is graph it. I provided graph paper in the test. So you go over 1 down 2, and this, whoops, let's try that again. Over 1 down 2, this is A, and over 1 up a half is B, and over 2 up 1 is C. So now I will connect those points. If you were doing this, obviously you'd use a ruler. Okay, so there's 1. Let me make that thinner, by the way. This doesn't look too good. Okay, so there's 1. Let's try that again. Red, thin, from A up to B, and from A over to my unnamed C. Okay, so there's the original triangle, ABC. Now I'm going to do the next triangle, DEF, and that is at vertices 4, -3. That's D. E is 4, 2, which is here, and F is 6, 3. So then when I go and draw those, let's use green and thin, then I go from D to E and over. So these are our 3 points, D, E, F. So there's the 2 triangles. So the triangles are similar because the dilation under what center? Well, let's do that. So then I'm going to switch to a line, and if I used a ruler, which you would use on a paper, you would draw a line through E, F, and see that it's on the same line as B and C. And there is our line reflection that are, so B extended to E on this trajectory. So one line isn't enough. We also need to do another point, which is this one, and go like so. Let me make that thinner. Let me see, click that, make it a little thinner so you can see better. Okay, and as you can see, A went down this trajectory to D. And the answer to this part of the problem is, where do those 2 lines intersect? It's right there, -2, -1. So the answer to the center of dilation is C, -2, -1. And scale factor. Well, all you have to do, the easiest way to do this, I gave a vertical line of 1, 2.5. So this AB is 2.5 in length. And this D is 1, 2, 3, 4, 5. So AB went from 2.5 to 5. Well, what do you have to multiply this by to get that? You have to multiply it by 2. Okay, so there's number 7. Number 8, the figure shows a circle with center P, diameter BD, inscribed triangle BCD, PC equals 10. All this is already labeled for us. And an angle CBD, let measure of angle CBD be X degrees. And the measure angle BEC CD, which is this whole angle here, equal x plus 54 degrees. Okay. So here, what are we going to do? Okay, so we have a theorem called Thales Theorem, and let me highlight this for you in a different color. We were told BD is a diameter. We also knew that because it's going through the center point P. And we have an inscribed angle BCD, which its endpoints intercept a semicircle. Thales theorem says the intercepted arc is, or the angle is 1/2 the intercepted arc. Well, the arc's 180 degrees, so the angle's 90. So this is in fact, oops, didn't switch back to my pen. This is in fact a 90-degree angle right here. Okay. And it said, let the measure of angle CBD be x and the measure of angle BCD be x plus 54. So now I know that x plus 54 equals 90 degrees. And that's how you do this problem. So you say x plus 54 equals 90. Subtract 54 and we get 36 degrees. So A is 36 degrees. And then it says, what is the length of CD? Well, if x is 36 degrees, so let me get that out of there now and put 36 in. Okay. And this is 90 degrees. Then this angle over here is 90 minus 36, which is 54 degrees. 54 degrees. Okay. So what else can we get from this? This is 10. This is 10. And this is 10. We already knew that. It was given. Why do I know these two are? Because they're all radii. What it is asking for is the length of CD. Okay. This radius and this radius make this triangle here. And let me draw outside so it's clearer. Okay, let's do this. Let's draw a triangle. Okay, and then I'm going to rotate it and make it look pretty close to the one that I took out. So you see right there, move this out here. We know this is 36 degrees. This has to be 36 degrees because these are both radii, they're congruent. That's an isosceles triangle. So the triangle sum theorem will find this angle here. So let's call that y. So y plus 36 plus 36 equals 180 degrees. Add these, y plus 72 equals 180 degrees. That would make y 108 degrees. So if this is 108, this is a linear pair. I also could have said, well, then this is 72 degrees because it's an exterior angle and these are remote interiors and it adds up. So this is 72, this is 54. And by the way, this angle here, right here, is also 54 degrees because this is a radius and this is a radius. So this is 54 degrees. 5, 4, 5, 4, 7, 2. Okay. So the length of CD here is the longest side of this triangle because it's opposite the largest angle. Okay. So it is greater than 10 degrees, than 10. It's longer than the radii because the measure of angle CPD is greater than 60 degrees. Okay, page 6 brings us to problem number 9. A spring is attached at one end to support B. Okay, here's the spring attached to a support at B. And the other end is attached to a collar at A, as represented in the figure. Collar A slides along this vertical shaft CD. In the figure, the angle theta is right here. created as the collar moves between point C and D. So as A goes up here, theta gets smaller. As A moves closer to C, theta will increase. Part A says when theta is 28, so the first thing I'm going to do is I'm going to draw a triangle. And I'm going to bring it in here so that we can work with a triangle that doesn't have all these shapes. Okay, so here's the triangle. It's going to be this triangle here. It's just enlarged so we can write in it. So when theta is 28 degrees, so that goes here. What is the distance from point A? Where's A? Down here to point B. So I want to know what this distance is right here. To the nearest tenth of a foot. Okay, hopefully, yeah. Read the directions. If you round to a whole number, then you lose points. All right, so enter your answer. So what do we have here? Well, we know that this side is 3 feet. That's given right there. So I know adjacent, I want hypotenuse. That's cosine. So cosine theta equals adjacent over hypotenuse. Okay, cosine theta is adjacent over hypotenuse. Substitute the givens. Cosine of 28 degrees equals 3 over x. I can just move this numerator over here. So it'd be 3 over the cosine of 28 degrees equals x. And I get my calculator out. Okay, and I will make sure mode is in degrees. Don't want radians, you'll get it wrong every time. 3 divided by cosine 28 equals 3.397. So x equals let's see, not 3.397. What did I do? Okay, that's correct. Just want to make sure. And 3.39 rounds to 3.4. So this is 3.4 feet. Okay. Now what we want to do is part B. It says when the spring is stretched and the distance from point A to point B is 5.2. So I'm going to erase this. And we now know that we're given this is 5.2. Okay. What is the value of theta? So now we know this is not 28 degrees anymore. This is our theta. So now I have adjacent and hypotenuse again. So it's going to be the cosine of theta equals adjacent over hypotenuse. So in order to find the theta, I will switch theta over here. Actually, I can move the word cosine over. So theta equals cosine, and if I move it across an equal sign, it's the cosine inverse of 3 over 5.2. Okay, so I just go to my calculator. For cosine inverse, you hit second and then cosine because it says cos to the -1 in blue here. Cos inverse of 3 divided by 5.2, and we get 54.76. Nearest tenth of a degree, can be careful, 54.8. So theta equals, or it's approximately 54.8 degrees. And that is C. Okay, number 10, a rectangle will be rotated 360 degrees about a line that contains the point of intersection of its diagonals and parallel sides. So the first thing I would do in this problem is draw a rectangle. So let me do that. Okay, so I read ahead a little bit. So I drew what it said. A rectangle will be rotated 360 degrees about a line that contains the point of intersection of its diagonals and is parallel to the side. Okay, I don't recall seeing any of my students drawing this diagram, but you should. So I drew a rectangle in black. Okay, the blue line contains the point of intersection of the 2 diagonals. So I drew 2 diagonals, and where they met, I drew a parallel line to the sides through it. So this blue line is parallel. So I could draw this parallel here. This is parallel to this, is parallel to that, is parallel to that. I also could have done it this way so that these 3 sides would be parallel. So now picture this thing spinning really fast around. What is that going to form? What shape? Well, it's going to form a cylinder. And I showed a video in class on that to explain this, but unfortunately, many of them did not get that. You do not get a rectangular prism or a cube. You will get a cylinder. Okay, picture a hockey puck. If you spin a piece of rubber that's this size around really fast, and it's so fast that it looks solid, it would look like a hockey puck. It is a cylinder. Okay, page 7 brings us to problem number 11. It says triangle ABC is shown in the XY coordinate plane. So here I drew it over top. The triangle will be rotated 180 degrees clockwise. This word is not necessary when we're doing this rotation. Counterclockwise, clockwise, does not matter. When you go 180 degrees, you're halfway at the same point. Around the point 3, 4. Well, that 3.3, 4 is around the point C. To create triangle A prime, B prime, C prime. So I'm going to do that. I'm going to rotate this 180 degrees. And then I'm going to move it so that C is still at C. Trying to get that to move just a little smidge right about there. Okay, so there is the 180 degree rotation. So let's now label this. B is here, this is B prime. A is here, A rotated around and it said clockwise. So we went this way and now A prime is here. C shares C prime because that was our point of rotation. So there is our rotated triangle. Okay, now let's answer these questions. The coordinates of A prime. Well, here's A prime. They are not the same. Okay. The coordinates of C, actually I shouldn't do an X, I should fill it in. The coordinates of C prime. Well, C prime stayed the same. That was our point of rotation. The perimeter, rotations preserve size. Perimeter will not change. Area, rotations preserve area. Size or preserve size, so area does not change. The measure of angle B, again, the shape is preserved, angle measures don't change. The slope of A prime C prime is going to be equal to the slope of AC because of the 180 degree rotation, and that's just going to be a continuation of a straight line. So that will also be the same. All right, number 12. The figure shown. This figure shows two semicircles with centers P and M. Semicircles are tangent to each other at point B. That just tells us they don't overlap. They touch right there at B. There's no overlapping and they are touching. There's no space in between. Ray DE is tangent to both circles E and F. That is the key to this problem. Okay, that right there saying that they are tangent tells me that these are points of tangent C, and I can draw a radius from P up to F and from M up to E and form right angles because points of tangency, radii, are perpendicular to the tangent line at the point of tangent C. All right, so that I just got from right there. Then it says PB equals BC. PB equals BC. So the radius of the circle P is equal to the diameter of circle M. Okay, and they're both 6. So PB is 6. Since that's a radius, AP is also 6 because that's a radius, and so is PF. All radii of the same circle. And then since BC is 6, that's the diameter. BM is 3, MC is 3, and ME is 3 because they're all radii. I just don't know this, let's call it X, and they want us to find ED, we'll call Y. Okay, well, as you can see, this is a right triangle sitting on top of another right triangle, sharing this angle here in each triangle. So we have angle similarity because that's a 90 degree angle. So when you have, that tells us the two triangles are similar. then that means the angles are congruent and the sides are proportional. So if I go from big triangle down to little triangle, I'll say big over little, just to keep it straight. The big triangle, PF is 6, is similar to, or it's corresponds to ME, which is 3. And that has to equal this whole side, the big side, which is 6, 7, 8, 9, 10, 11, 12, plus x. 12 plus x. Okay, hopefully you understood that. And now let me get rid of that. All right, going to do the same for the little side. So this side here is 3 plus x. Hopefully you see that. 6 is to 3 as 12 plus x is to 3 plus x. Okay, so let me get rid of this now. There is our proportion. We can reduce this to make it easier. 6 over 3 is 2 over 1. And that still equals 12 plus x over 3 plus x. Cross multiply. 1 times 12 plus x is 12 plus x. 2 times 3 plus x is 6 plus 2x. Subtract this x over the other side. I'm going to get 12 equals 6 plus x. Subtract 6 over here. I get x equals 6. Okay, so now I'll erase this and put a 6 here. So now I know the hypotenuse is 9. Okay, hopefully you followed that. And I now know that this is 3 and this is 6. I can find this. Pythagorean Theorem. A squared plus b squared equals c squared. Your c is your hypotenuse, so make sure you put the 9 over here. A, 3, and we're trying to find y. So it's 9 plus y squared equals 81. Subtract 9, y squared equals 72. Take the square root of both sides, and y equals the square root of 72. Okay. All right, page 8, question number 13 says the figure shows line AC and PQ intersecting at point B. A prime C prime and P prime Q prime will be images of line AC and PQ respectively under dilation with center P and a scale factor of 2. So what that means is if this is a distance of 1, we're going to double that now, and we're going to put P. We're going to scale everything up by that distance of 1 plus 1 or 2. So what I would do is, let's move this to here, and this. Oops. Can't get a hold of that. There it is. Oh, I don't want to enlarge it. I want to move it. Hello. All right, right there. Okay, so think of it as that. The distance from B to Q is this, and we want to double that distance. So what this problem is telling us to do is to move, and it says the dilation with center P is going to move B instead of this distance from P, another distance. So it would end up actually probably on Q. On Q, get it? All right, so anyway, that's what's happening. Whoops, I can't hit that and hit delete. Why is that doing that when I hit delete? All right, just a moment. Where did it go? Oh, all right, so this is now dilated, a double. I won't delete those then, how's that? All right, so it says line A prime, so here's A prime now, and here's C prime. So now this red line, A prime, C prime, the whole thing got shifted down away from P. Okay, well these would actually dilate out this way, and the dot would end up over here, And if we doubled it going this way, this C prime would actually be out here. So it's stretching the line out as it pushes it away. Think of it that way. And then line A prime C prime will be parallel to the original line. So if you're moving this line away from P, it's going to be the new line, the image of the pre-image will be parallel to the pre-image. So line A prime C prime will be parallel to AC, comma, and line P prime Q prime. So now this is P prime stays right where it is. This is now Q prime down here. It's still on that same line because its trajectory is that line. So line P prime Q prime will be the same line as PQ. So it's C. All righty, number 14. In the coordinate plane shown, a triangle ABC and triangle DEF has vertices -4, 6, 2, 6, and 2, 2. That's the big triangle. What is the scale factor and the center that carries ABC to DEF? Okay, so for starters, scale factors, R is greater than 1 is an enlargement. R between 1 and 0 it shrinks. Okay, keep that in mind for starters. We are going from ABC onto DEF. DEF is smaller than ABC, so I need a fraction less than 1 for an answer. Some students answer this 2. They went the wrong way. All right, enter your answer in the box, complete the sentence. The scale factor is, well, to find the scale factor, you count the length of a side. BC is 1, 2, 3, 4. This is a length of 4. EF is a length of 2. I went from 4 to 2. 2 is half of 4, so the scale factor is 1/2. All right. All right. Then it says, where's the center of dilation? All right, so let me do this a different way. Let me do it in here. And so what I do to find centers of dilation, I draw a line from a point through its corresponding point, like so. So A move D along this red line. I'm going to repeat that for the others. I'm going to go through B, E, like so. And let's make that thinner because it's hard to see. And do that. And then finally, if I did the same, draw a line segment, thin, C through F, like so. And make that one red. There are our 3 trajectories, and they meet right here at the origin. So let me go back to my other one. So the answer is going to be 0, 0. Okay, page 9 brings us to problem number 15. The figure shows parallelogram ABCD. Keyword right there, parallelogram. Do you know your parallelogram concepts, or all the properties, I should say? Opposite sides are parallel. So this is parallel to this. This is parallel to this. Opposite sides are congruent. Okay, for parallelograms. And diagonals bisect each other. So this equals this, and this equals this. All right, we're given AE is 16. Part A says let BE be x squared minus 48. So BE is right here, x squared minus 48. And DE is 2x. Well, since these are diagonals and they bisect each other, then each piece is equal. So I say x squared minus 48 equals 2x. In order to solve this, we have a squared, we have an x, we want to move everything over to one side and create a quadratic. So I'm going to subtract 2x. So I'm going to get x squared minus 2x minus 48 equals 0. I just put that in standard form. And then I'm going to factor it. So x times x is x squared. And I'm looking for factors of 48 that add up to 2. And they're opposite signs, so I'm going to put a plus minus. 6 times 8 is 48. I need the 8 to be negative to get a negative 2. So therefore, x equals negative 6 or x equals 8. We're talking about distance here. Distance can't be negative. My answer is x equals 8. DE is equal to 2x. BE is x squared minus 48. So to answer BE, I'd say x squared minus 48. Okay, equals BE. So I'll say BE equals. So therefore that equals 8 squared minus 48, which equals 64 minus 48. And that is 16. DE equals 2x. DE equals 2 times 8. So therefore DE equals 16. Okay, so that's the answer to this problem. Notice it says not drawn to scale. That's a good thing they put that there, because this would actually, the only way this could happen where the diagonals are equal is if this was a square. But squares are parallelograms, so I guess that's okay. But anyway, the answer is 16 and 16. All right, number 16, the figure shows two perpendicular lines, S and R. Okay, so they're 45-degree angle, like so, intersecting at point P in the interior of a trapezoid. Line R is parallel to the base. Okay, so notice how I'm doing this. I'm labeling everything it says. Line R is parallel to the bases. All three bases, the two bases and the line are parallel. And bisect both legs of the trapezoid, which means that's equal to that, and that's equal to that. Line S bisects both bases of the trapezoid, which means this equals this, and this equals this. Okay. Which transformation will always carry the figure onto itself? Select all that apply. So in order to answer this problem, I recreated this trapezoid with line segments that I can manipulate. So a reflection across R. A reflection across R would be the same as a rotation. So if we reflected across R, it would end up like that. Okay. Okay, it would end up like this. It obviously is not on top of itself. A reflection across S. Okay, here's S. Well, that would flip it this way, and it would land on top of itself that way. So that's a reflection across S. Okay, a rotation 90 degrees clockwise. There it is. Is it on top of itself? Nope. A rotation 180 degrees. That's the same as a reflection across R. Nope. A rotation 270 degrees. Again, nope. So these are all no's. So the answer is B. Okay, number 17 says an archaeological team is excavating artifacts from a sunken merchant vessel on the ocean floor. Okay. To help with the exploration, the team uses a robotic probe, which is right here. The probe travels approximately 3,900 meters at an angle of depression of 67.4 degrees. So there's the distance of this. Okay. Angle of depression means that it's an angle with respect to the horizon. So if you're standing here looking straight across and then looking down, depression down, this is the angle of depression. An angle of elevation would be sitting here looking up from the horizontal ocean floor. And depressions and elevations are congruent. So this is going to be 67.4 degrees as well, right down here. 67.4 degrees. Okay, so this angle here as well. The figure shows a representation of the team ship and the probe. When the probe reaches the ocean floor, the probe will be approximately blank meters below the ocean surface. So below the ocean surface is a straight shot. That means from here, straight down, like so. And actually, we could probably put that over here as well. So the angle of depression is what we would use here. So let me just erase this, just showing another fact. So there's our right triangle, and we want to know what this length is when the hypotenuse is 3,900 and this angle is 67.4 degrees. So I want to know opposite, and I do know hypotenuse. So that would be sine of the angle. And that's how we would do this problem. So the sine of 67.4 degrees equals opposite, actually let's call it y because it's vertical, over adjacent, or hypotenuse, I mean, which is 3,900. In order to get y by itself, we multiply both sides by 3,900. And we put in the calculator 3,900 times the sine of 67.4. Okay. So make sure you're in degrees, but I already am. 3,900 times the sine of 67.4 is 3,600. So the answer is E. Okay. Continuing on. It says when the probe reaches the ocean floor, the horizontal distance of the probe behind the team's ship on the ocean surface will be approximately what? So what they mean there is, here's the back of the ship. Okay. How far is this distance? I'll call it X. There's our right triangle. This is now 67.4 degrees because it's the floor is parallel to the water, and that's a transversal. Alternate interior angles are congruent. So 67.4 degrees is this. We know the hypotenuse. We do not know our adjacent. So we want to know the adjacent. We know the hypotenuse. That is cosine of an angle. So the cosine of 67.4 degrees equals adjacent over hypotenuse. To solve this, we multiply both sides by 3,900. And we put that in our calculator. 3,900 cos 67.4 m. And I got 1,498.7, which is pretty darn close to 1,500 meters. Number 18. Triangles ABC has vertices at A1, 2, B4, 6, C4, 2 in the coordinate plane. The triangles will be reflected over the x-axis, then rotated about the origin. What are the vertices? So the way I teach this is you pick a point. I just usually try not to use one. I'll focus on C, 4, 2, and I'm going to graph it if you don't remember the rules. Okay, so I brought in a piece of graph paper, which was provided, and we have the point 4,2 right here. All right. It's reflected over the x-axis, which is here. So move 1, 2 to get to the x-axis, move 2 more, that'll get us here. So we went from 4,2 to 4, -2. So the rule would be x, y goes to x, -y. That's step 1. Then it's rotated 180 degrees. So if I call that, no, it was C, let's call it C. This is C prime. And now we're going to rotate 180 degrees. So, okay, so what I tell students to do then, well, if you're going to rotate 180 degrees, it doesn't matter clockwise or counterclockwise. What I'm going to do is just take my piece of paper and rotate it upside down. So if I rotate this now follow C prime, Where does C prime end up when I rotate 180 degrees? Pretend these numbers aren't upside down. I went 1, 2, 3, 4 to the left, which is -4, comma, up to 2. All right, so that's my C double prime. So then I went, my X comma Y became, so instead of, let's just skip the middleman now. What's the rule for going from the original C of 4, 2, right here, over to C double prime of -4, 2? Well, what happened? The X became negative, the Y stayed the same. So it's -X comma Y. So here is the rule we would use for every single point. X became negative, Y stays the same. -1, 2, this is not right, this is not right. -1, 2, this is not right. -1, 2, this would be -4, 6, -4, 6. This would be -4, 2, -4, 2. The answer is C. Okay. Okay, question 19. Question 19. Okay, Cavaliere's principle states that if you take something that has a certain volume and you just push it over, it will still have the same volume, basically, in a nutshell. And all of its cross sections will be congruent to the base. So 2 cylinders, each with a height of 50 inches, are shown. Which statement about the cylinders are true? Select all that apply. If the radius of X equals the radius Y, the volume of P is greater than? No. They have the same height. If their bases are the same, area is pi r squared. So if X and Y are equal, then their bases are the same. And same times height will give us the same volume. X equals Y, then the volume is equal to the S because the cylinders are the same height. This says if X equals Y, the volume of cylinders is less than. No, it's not. D, if X is less than Y, the area of the horizontal cross section of P is greater than? No. P contains X. If X gets smaller, then the volume gets smaller. Okay, so it's not greater. If X is less than Y, the area of the cross section of P will be equal to? No, it won't. If X is less than Y, the area of the horizontal cross section will also be less than. And that answer is F, simply because area and volume go hand in hand. All right, number 20. Okay. Have a triangle. The measure of angle B does not equal C. This is not an isosceles right triangle. Sine of B equals R. Well, the first thing we're going to do, let the opposite side of B be side B, or the opposite side of angle B be side B. Opposite side of angle A is side A, and opposite side of angle C is side C. All right. It doesn't look like a very good A. Let's make a new A. Okay. So let sine B equal R. Well, what is the sine of B? I'm going to write that. So the sine of B equals R. But what does the sine of B equal as a ratio? Opposite over hypotenuse, B over A. So transitive property then tells us R equals B over A. See how easy that is? Cosine of B equals S. So S equals cosine B. Well, the cosine of B is adjacent over hypotenuse, or C over A. Transitive property then says S equals C over A. All right, so now it says, what is the sine of C? Well, the sine of C equals, here's C, opposite over hypotenuse, C over A. Now I'm going to substitute C over A as S. So the sine of C equals S. Minus, so we're subtracting, the cosine of C. Well, the cosine of C equals adjacent over hypotenuse, which is B over A. All right. But B over A is R. So the cosine of C equals, the sine of C equals S. And let me just write it like this. I don't want to do the minus yet. So therefore, get rid of that. Cosine of C equals B over A, which is R. All right. So now we want to do sine of C minus cosine of C. Now I substitute, sine of C is S minus cosine of C is R. So the answer is S minus R. Okay, so that is the end of the test. Hopefully that was helpful to you, and have a great summer.